And now we turn our attention to the problem where you have to solve the pool perimeter situation here. We're going to turn our attention to this problem right here. We're given this diagram of a pool made up of circles and straight lines, basically. We want to know the perimeter of this pool, the distance around the pool here. That's what we're going to find for the perimeter. The pool's perimeter, the distance around this pool, is made up of three lines, right? You got this line right here. That's 32 feet. Up here you got the same line that's 32 feet. Alright, and then you got two small portions of smaller circles right here. You got this little portion right here. You got another portion right here. And of course you got that straight line right there also. And over here you got half of a bigger circle. That makes up the perimeter right there of this figure. Okay, so we're talking circles. We're talking perimeter of an area dealing with circles. The distance around a circle is called the circumference. So we're going to use this formula right here from your reference sheet. The circumference is pi times diameter. Right, diameter distance across the circle. Okay, so once again, the pool's perimeter then is made up of three lines. Right, there's a line here. There's another line right here. And then we also have the third line right here. And we also have a part of a circle right here. Another part of the circle's circumference here. And half of the circle's circumference over here on the right side. Okay, there's the small circle right there. We have the same circle right here. It's the same size circle. All right, and they both have a radius of 8 feet. So the diameter would be twice that. Okay, so the circumference of the small circles is 16 times pi. Okay, where did we get 16 from? 16 is the diameter of the circles. Diameter times pi to get that circumference. 16 times pi, right? 16 is the diameter. I have 8 for my radius, so the other all the way across the circle then would be twice that 8, which is 16. Okay, so the circumference of the small circles is 16 times pi. Okay, so that means that each of these small circles is 50.24 feet around, right? This dashed line right here, center around, is 50.24 feet. Now we only have a fourth, though, right? A fourth of that circle right here, and a fourth of that circle right there. So to figure out how much the small circles are contributing to this perimeter, I'm going to take a fourth of that circumference of 50.24. So then we get 12.56. So that small section up here, this small section right here is 12.56, and so is this portion up here. Okay, each of those is 12.56. Okay. Okay. All right, now we can turn our attention to the big circle. The circumference of the big circle would be 26 times pi, right? Because it's the diameter times pi. This time the diameter is given for us. We're not given the radius, we're actually just given the diameter. So this circle is 26 feet across, which means that its circumference, the distance around it, is going to be 26 times pi. Okay, so then that's the circumference. 26 times pi is 81.64. But again, we're only concerned with half of this particular circle. So to figure out the little section right here that's contributing to the perimeter, I'm going to take half of 81.64. So this section right here is 40.82. Okay, so to get your final answer, you're going to add this segment right here that we found a little while ago here. Right? Add this segment also. We solved that one a couple slides ago. We're going to add this straight line to it, this straight line to it. We're going to add this half a circle part right here, and this straight line portion also. So the perimeter of the pool is going to be the sum of all of these little segments right here, whether they're straight lines or parts of a circle. Do that, you've got your answer.